Okay, so step one of the refrigeration cycle starts off in the compressor, which is essentially the heart of our system, and it always keeps the refrigerant moving. The compressor's job is to take the low pressure, low temperature vapor that's coming in from the evaporator, and it squeezes it over and over again until it turns into a high pressure, high temperature vapor. Compressor's electric motor, whether it's a reciprocating motor, a scroll motor, or a rotary motor, continue to squeeze the vapor until it's superheated, and then once it's superheated, it's past its boiling point of that pressure. It's ready to head to the condenser coil. Okay, so the next step is the condenser, and the condenser's job is to remove any heat that the refrigerant picked up from the system. After leaving the compressor, the high temperature, high pressure vapor flows through the condenser coils. As the vapor moves through the coils, it transfers heat to the surrounding air, and the fans inside the condenser help speed this process of removing heat by increasing the airflow on the coil's surface. As the refrigerant loses its heat, it starts to condense, which means it changes from its vapor form originally and back into a liquid. This phase change happens at constant pressure, but with a big drop in temperature. By the end of the condenser, the refrigerant has turned into a high pressure liquid, still warm, but not hot like it was coming out of the compressor. That liquid refrigerant moves on to the next component of the refrigeration cycle, which is the expansion device. Okay, so the next step, the expansion device, which is basically like the gatekeeper. It separates the high side and the low side of the system. And basically what happens is when the high pressure liquid refrigerant passes through the expansion device, it experiences a sudden drop in pressure, and because of the sudden drop of pressure, part of the refrigerant instantly flashes into a vapor, and the temperature of the vapor drops dramatically. The refrigerant coming out of the expansion device is now a low pressure, low temperature mixture of liquid and vapor. It's not cold enough yet to freeze anything, but it's enough to absorb some heat, and that's exactly what it does next in the evaporator. So the next step is the evaporator, and the evaporator is where the cooling actually happens. It's the part that absorbs heat from the space you're trying to cool. Inside the evaporator, the cold, low-pressure refrigerant mixture enters the evaporator coils. As the warm air from the room blows across these coils, the refrigerant absorbs that heat, and as it absorbs this heat, it boils, changing it from a liquid back to a vapor. Even though it's boiling, it's not hot at all because it's boiling at a low temperature because of how low the pressure is inside the evaporator. By the time the refrigerant is ready to leave the evaporator, it is now returned back to a low pressure vapor again. Sometimes this vapor in the evaporator is superheated, just so it prevents any liquid from re-entering the compressor, as that would cause a lot of damage to the compressor. And from here on out, the vapor is ready to enter the compressor again, and the cycle would restart again. Okay, just a quick summary, just to put it all together. The refrigerant starts off in the compressor, where it takes in a low temperature, low pressure vapor, it compresses it into a high pressure, high temperature vapor, and from there, it leaves the compressor and enters the condenser, where it releases this heat, turns the vapor back into a high pressure liquid, and from there, it leaves the condenser, enters the expansion device, where it drops the pressure, it cools the refrigerant down, and creates a low pressure liquid vapor mix. And from there, it leaves the expansion device, enters the evaporator, and the evaporator absorbs the heat and evaporates the refrigerant back into a low pressure vapor. And from there, the cycle loops back again, where it leaves the evaporator and enters the compressor again.